Welcome back to CRISPR Corner. In this series, I've talked a lot about guide RNAs, but one thing we haven't talked about is how to design guide RNAs. Until now. In this episode, I'm going to be giving you a few tips for designing guide RNAs for gene knockout. In theory, any 17 to 20 nucleotide sequence in the genome that's followed by a PAM site is a potential guide RNA. But not all potential guides would be good guides. So how do we design a good guide RNA? First, we do our homework. Learn everything you can about the gene that you want to knock out in the model system that you're using. How many different isoforms does it have? Which exons are present in every isoform? Which exons are essential for protein function? What is the chromatin structure? Are there multiple transcription start sites? The more you know about your gene, the better. Next, here are some basic rules that we follow when designing knockout guides. Number 1, hit every transcript. If you are aiming for a complete knockout, you want to target a sequence that is present in every isoform. Number 2, target an early exon, but avoid the first 90 base pairs. This rule helps in 2 ways. First, by helping to ensure that we generate a frame shift or premature stop codon early enough in the coding sequence to ensure a non-functional protein. And second, by helping avoid alternative start sites that may be present. Number 3, choose guides with a GC content of 40 to 60%. GC contents that are too high or too low can result in lower cleavage efficiency. Number 4, use guides that have a greater uniqueness in the genome. 3 or more base pair mismatches is our rule of thumb. Number 5, have an efficiency score and specificity score of greater than 40. Number 6, test at least 3 guides per gene and avoid having them overlap. Even within a 50 base pair window, guide activity can vary drastically. Testing multiple guides helps ensure that you find at least one that effectively knocks out your gene. Number 7, if your guide will be expressed from a vector using a U6 promoter, avoid guides with more than 4 Ts in a row. If you're using an RMP format or a different promoter to express your guide, you can ignore this one. And lastly, you know what they say, rules are meant to be broken. Break these rules when you need to. Ultimately, biology has the final say, and your gene of interest may not have guide sequences that nicely check all these boxes. In those cases, you may need to break a rule or two, or maybe even consider a different approach. Nowadays, there are a ton of design tools and pre-designed guides to help you on your CRISPR journey. I'll walk you through a couple of those in another episode. In the meantime, if you want help with guide RNA design, want to chat about designing guides for CRISPR-I or CRISPR-A, or anything else in the CRISPR world, let's connect.